responsible for propagation of rip carry all the way from input to the output in the worst case. So that would be the T of AND OR gate, because inside these boxes we have two input AND and two input OR gates. Plus we have the T sum, which is equal to T XOR. So this is what the expression for the ripple carry adder. Now we see that as n increases, this means that TRCA increases linearly. So if we have 16-bit adder, this will be quite slow. If you assume all these functions have the same delay, then it will be 16 minus 1 into 1 plus 1 is equal to 17. Assuming that all the gates have the same delay, which is not the case in reality. So we have to figure out how we can improve the performance of adders when it becomes becomes 16 or greater. So it could be as high as 32 or 64, because most of the processors use 64-bit. So 64-bit adder inside a processor is quite common, even 128 also. So we need to find out what we can do to improve the overall delay. So we'll be discussing some of the configurations which you may be getting familiar with respect to your CAD homework. One is called carry bypass adder. Carry bypass adder, CBA. Sometimes it's called carry skip adder, CSA. But then there is another thing called carry select adder, so that's why I prefer CBA. So the idea is that if you have n bits, then we can divide them into chunk of m bits, and so on. So we will have n by m chunk of n bits. Now, the idea is, first of all, our job will be to find out how we can reduce the delay, because this delay grows linearly. So if we take an example of addition of A plus B, the two numbers, say 0 through 15 plus B 0 through 15. So A and B are 16-bit numbers, and if A is equal to F, 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 F in hexadecimal, that means all the bits of A are 1, and B say 0, 0, 0, 0, all are 1. And this is saying the least significant nibble, because 4 of them are there. 4 bits together is called a nibble. So then if I change the least significant bit in the least significant nibble from 0 to 1, then what will happen? Then we'll see that the result of addition will be the carry which will be generated in the first bit, because it will be 1 1, so it will be 0. Then that carry will be propagated to the next stage. So this will be 0, 0, 0, and this is carry. So these are all 16 bits, 0, and this is 1, the carry out. So the delay associated with this is equal to n is equal to 16 different stages of AO gates. So our idea will be that can we divide n into smaller chunks of m bits, and we'll be using RCA within the m bits. So we'll have essentially n by n RCA of m bits. So if I do that, then I can take care of this situation. Instead of delay propagating through this, I see that the carry was generated in LSB and carry was propagated for all other bits. So this is the worst case example. So in the worst case example, what I see is that if these are, let's say m is equal to 4, to make it simpler first. So if this is f, this is f, and this is f, and then we are adding it with 0, 0, and the last bit 1 over here, then we see that, or rather, let's make this is the least significant bit because that's how we are used to. So if you're adding f with 0, first 0, 0, 0, then the result will be FFF, and then I change the last bit to 1, then I'll have the situation like this. The carry out will be coming out here is equal to 1, and rest of them will be 0, 0, 0, 0, 0. So what do I do? I don't want the carry to pass through all of them, because then we'll have the delay like this. I would like to reduce the delay by introducing multiplexer after each n bits. And these multiplexers will be sensing the propagate function P0, P1, P2, P3. Similarly, here P4, P5, P6, P7, and so on. Okay? So now, since this is F0, so all these P4, P5, P6, P7 are 1, so the multiplexer will be selecting corresponding to the input 1. Here, P0 is 0 because carry is generated and rest of them are P1, P2, P3 are 1. So here the multiplexer will be selecting from the upper place. So this is how I would be able to transfer the carry which is generated in the first stage over here after it propagates through the first n bits in the RCA all the way into the output. So this is the way I can reduce the delay considerably information on generation terms, which in your slide you'll see that is written as a setup. Setup is basically the delay associated with the TPG, which is the maximum of T of XOR and T act. And then the worst case scenario that all of them are 1 P's and A 0, 0, 0, except the least significant bit changes from 0 to 1. So here, A is 1, B is 1, so that is carry is generated. So carry is generated G. And rest of the cases, A is 0, B is 1, so carry will be propagated.